Hello, Hopewell. This is Mr. Steinberg. Today's lesson, 9.6, using the law of cosines to solve triangles. Last week we learned the law of sines, and we used the law of sines when we had certain conditions like angle, angle, side, or angle, side, angle. Pretty much, I don't really bother learning those letters and the relationships. What I do know is we would use the law of sines when you have a side length that's across from a measured angle. If you know that relationship of an angle and it's across the triangle side length that corresponds to it, you would use something called the law of sines. We also learned something called the ambiguous case, where we had little side, long side, and angle. And there may be two potential triangles or only one triangle to solve, a unique triangle, or no triangles given that information. Today's lesson we're using the law of cosines. The law of cosines is used when you can't use the law of sines, so you don't have a side length across from a measured angle. This would be used for things like side, side, side. If you're given three sides like side A, side B, and side C, and you wanted to find the angles across from them, you would use this formula. Or something like side, angle, side. If you have a side, an angle, and another side in that order, then you would be able to use it to find the third remaining side length. The formula works a little bit like this. It starts out looking like the Pythagorean theorem, where c squared equals a squared plus b squared. Then there's one extra term, minus 2ab cosine c. What you'll notice is this is the only angle measure, angle c. The other a's, b's, and c's are all lowercase, which means they are side lengths. Now, important to notice, this is not the only version of the formula. There are other variations that you can use. For example, if you weren't given angle C, if you were given angle A, your formula might look like this. A squared equals B squared plus C squared minus 2BC cosine of angle A. If you were given angle B instead of A or C, you would just do this. B squared equals A squared plus C squared minus 2AC cosine B. So there are other variations of this formula. Any of them will work, but you have to use the one that's given the information that you have. You have to use and pick and select the right one. Speaking of which, I'm probably going to end the video with this first exercise. There's a lot into this. So we have triangle ABC. We're going to try to solve, finding all the missing pieces. Given this situation, I have side length A is 11 units, side length C is 14 units, side length B we don't know, but we do know angle B is 34 degrees. Since I don't have an angle across from a side length, I cannot use the law of sines. I have to use something different. Since the only angle I have is angle B, I'm going to look at the third variation of this formula. B squared equals A squared plus C squared minus 2AC cosine B. So what I'm going to do is I'll set this up. I'm just going to write it out. B squared equals A squared plus C squared minus 2AC cosine B. Now I'm going to start filling things in. I don't know the value of B squared, although that term is isolated. That's a good start. 11 squared plus 14 squared minus 2 times 11 times 14 cosine of 34 degrees. So we plug in all the information we can, and to solve for B, all I need to do is evaluate this. Try to make it a little bit clearer. All I need to do is evaluate this right-hand side and then get rid of that squared by square rooting. Your calculator does a great job of doing this, so I'm just going to let it do its thing. Also, make sure that one more time, because we're given an angle in degree mode, we want to make sure our calculator is in degree mode instead of radian mode. Anytime you reset your memory or you plug in new batteries, it might default back to radian mode, so I always check. Can't hurt to be safe, right? So I'm always plugging in my values inside sets of parentheses. It's hard for me to do two things at once, but I'm doing the best that I can, and I know so are you. So let's see, we got 34, and I know it's in degrees. I'm going to hit enter. So 61, this would be the value of B squared, and 61 as a side length doesn't really make sense according to this, because it should be the smaller ones. I imagine these other angles have to be larger than 34. So what I'll do is I'll write it down just as a step. It's my work, so I can show my work this way just by writing this whole entire decimal down. Next, we're going to square root, and again, to get the exact answer, I'm going to hit the second and the answer key on my calculator, and then that puts the answer right into that radical. It gets me an approximated value. Actually, that gives me, I mean, this would be an irrational number probably. So this gives me a value of 7.852. We're going to round to 3 decimal places. Units. Okay. Now here's why I'm going to spend the rest of the time just doing this one exercise. Is because when you get into this situation, you know, I can use the law of sines now that I have a side length across from a known angle. But we're in a bad position here, and I'll explain why. This, if I was going to say, let's find angle A. And if I was going to use the law of sines, this is what would happen. I would have angle A, I need to use the 11 and the 14 and find angle A. Now the 14 doesn't have an angle, so I really can't do that. So I do need to use this and that. I need to use B and B. I need to use angle B. This and this relationship to find the measurement of angle A. This is the short side. This would be a short side. Long side angle. Let me say that again. This is the short leg or side length. This is the long side length. This is the angle. If I'm trying to find A, because these are across, I need to use it. I don't have an option. Because this is the side length across from A, this is the ambiguous case. So I might have 2 different answers. So I have to be careful when I do this. Let's say I was trying to find C anyway. Let's try C then instead. I'd have to use this and this. Short side, long side, angle. We got a problem. This is going to be the ambiguous case either way. If I go in this direction, small side, long side, angle, that's ambiguous case. There are possibly 2 answers to this. So I'm going to play it safe. I'm going to use the law of cosines to find either of these angles. I'm going to try to find angle C because something down here tells me I should do that. So let's find the measure of angle C, but I'm going to also, like I said, I'm going to use the law of cosines that I had up here to find angle C. So that means I need to plug in the values of A, B, and C everywhere and then find this angle. Because we're finding an angle, we may have to do some sort of inverse trig. So let's do C squared equals A squared plus B squared minus 2AB cosine of that angle C. So if I use the law of cosines, then I will save myself from any sort of potential error when I use the ambiguous case. Also, I'm going to use this exact answer even though my work doesn't show that. I wrote down all of the decimals for it. But I always want to use the exact answer as best as I can. I try to make this focus a little bit better. Now, we got to be careful when we calculate this. This is a constant, this is a constant, this is a constant, and this is a coefficient of the cosine. So I can't really treat this as constants like these. But I can move these to the other side, and I'm going to do that arithmetically using my calculator. So what is 14 squared? Now I'm going to move this to the other side. So I'm going to minus 11 squared. I'm going to move this to the other side, minus the answer squared. Okay, then I'm going to need to take care of this. I need to divide this. So I'm going to hit divided by, and I'm going to start a parenthesis here because I have a large expression coming in. Negative 2 times 11 times my answer. And unfortunately, I just realized I used my answer. I already hit enter, so this is not going to work for me. So what I'm going to do is, instead of doing this, I do have to type the number as best as I can, replicate it using all of our decimal places, because I probably should have done this all in one step algebraically. This is going to leave us with negative 0.0772. I'm going to write it only an approximation down here, but I am going to use as best as I can use my calculator to do this. So it looks like to find the angle C, I need to inverse. So I'm going to do second cosine, and then I'm going to use second answer. That'll put the whole decimal back in there, and it tells me that it's 94.403 degrees. So the measure of angle C is 430 degrees. Okay, and that's an approximated value. We got it as best as I could here, but I rounded 3 decimal places. Okay, so now here's why I'm pretty sure that that this is going to have only one answer. Do you notice this is more than 90 degrees? And if I had used the law of sines and I did a sine inverse, the sine inverse for a positive ratio is only going to give me an answer between 0 and 90. And this angle is not between 0 and 90. So it was actually the supplement. It would have been like the second way of calculating this triangle. So I don't have to worry about another potential answer. This tells me that I only have one answer. How come? One more time. Because if I had done the law of sines to solve for angle C, it would never give me this as an answer. If I used the law of sines, it would give me an answer between 0 and 90. And its supplement would be the actual one that works. Having said this, now I know angle C is approximately 94.430. I think what I can do is I can now solve the triangle because I have the 2 angles, and I know all 3 of them have to add up to be 180. So I'm going to take this, I'm going to add 34 to it, take the answer and subtract the answer from 180. This will solve our triangle. The measure of angle A is approximately 51.569. Oh, that's going to round up. 570 degrees, and that's our measure for angle A. This solves our triangle. Just to confirm this, let's say I did use the law of sines if I switched it. Let's do the sine of 34 divided by 7.852, and I'm going to get that answer back again, divided by the sine of angle C divided by 14. Cross multiply, divide, and take the inverse. Because I want this value as close as I can replicate it again, I'm going to have to bring back that decimal, which I see is here. It's written in there. So I'm going to try to match and replicate this. So what's 14? 14 times the sine of 34 degrees. And then I'm going to divide it by that whole decimal, which I see is still up my screen. 7.8521607. That's as best as I can do. And then I need to sine inverse this. Sine inverse, second answer. Look at this. 85.5698, and then a bunch of 7s. Now that would be the measure of angle C, but that's not what we got when we used our law of cosines. So basically I would have switched the law of sines to solve this triangle, except we noticed there was an ambiguous case. Now I'm just wondering, if I take 180 and subtract this answer, does that give me the, oh yeah, it was the supplement that we wanted anyway. So we do have to be careful when we solve these law of cosines, because we might fall into a law of sines trap for an ambiguous case. We're going to move on to the next video. I'm just going to stop here because that was a lot of information. Feel free to play that one more time. I'm going to explain it again as we go through it. So let's continue on to video number 2.